started working with matrices, and we go row by column. So 1 row, 2 columns. 1 row, 4 columns. 3 rows, 1 column. And that we consider a square, 3 by 3. 3 by 3 is a square. So we're good with the square parts. All right, stop me if you have any questions. 2 by 2? 2 by 4? Good? 2 by 2 is a square. Yes. Okay, now, can everybody put this in and do RREF and find the solution? Okay, you don't have to use REF. REF, when you use REF, you then have to substitute back. What we do is, Manny, I'll run through this. You have a calculator? Yes. Handy? Okay. So let's just bring Manny up to speed, because without putting a matrix in, it's hard to understand what we're doing. So we're going to do this. We're going to do second matrix, because matrix is the blue. We're going to go over to edit, kind of like you do with L1, L2. Now, we're going to give it our dimensions. This has 3 rows, 4 columns. So we're going to tell it it's a 3 by 4. Put it in and just hit enter. Whatever's here, we're going to write over it. So we're going to put these numbers all the way across. It's going to flip to the next line. We got these because there are equations that look like this. Okay, here's your equal sign. We pulled out all the coefficients. When you solved all your systems of equations by hand, like if we didn't have a z, we'd take this, we would eliminate a z, then we would do 2 more. Well, we're going to do this in your calculator. So we pull out all the coefficients. These are the coefficients. This is the constant. So we're going to put this in your matrix. So as you do this, just put it in your matrix, 1 at a time. Just say 1, enter. Make sure you enter after each one. 2, enter. 3, enter. And keep going all the way across. It jumps to the next row. -1, 4. If you make a mistake, just go back over it. -5, 2, 6, 3, 10. Now, the last one, make sure you enter. And at the last one, you have to say second quick. Did you get it all in yet or not? Not yet. Good. Second quick. And now we're going to come back and we're going to go back to matrix, go to math, and we didn't do RRF, we did RREF. So we pull up we go to math, we scroll up or down so you see RREF and hit enter. Now, in order to tell it what matrix we had, we say second matrix. Whoops. Sometimes my calculator is not cooperative. Second matrix.
Not working for you?
No. There it goes. And we tell it it was A. So now we hit enter, and it gives us this back. If it's all decimals all over the place, we're going to go math, enter, enter, and put it back into fractions. Now what this tells us is this. This is the x, y, z. X is on, y and z are off. So x is equal to this value. X is off, y is on, z is off, so y is equal to this value. They're off except for z, so z is equal to this value. So that solves your whole systems of equations without you algebraically going through doing it. We use a matrix to solve it. We could do REF. What REF does is gives us a little bit different, starts us out, and we have to back substitute. But our REF is just a little bit nicer. So you'll kind of see this as we go through. And then you have to back substitute that. So I just told you guys just do RREF. And you're okay with this and you got this answer?
Mm-hmm.
Yes? Tell me if you didn't. This one had no solution. It probably had all zeros in the bottom. I did an REF on this, not an RR. It probably had all zeros, so this one had a no solution. And there are times that we don't get solutions. The REF gives you a little bit more work because you have to keep going backwards, but the REF goes right to the answer. Good? And I think that was the last one. I'm going to just go element for element. This is 2 by 3. This is 2 by 3. So when we add them, let's just look at how you would physically add them. You would take this element and this corresponding element and add them. So your result, this one would say 1. Take this element and this element, add them. This element, add them. So you see what we're doing? Corresponding. Because if I put this on top of this one and combined all their elements, this element and this element, add it. This one, add it. This one, add it. There's my resulting matrix. It has to have the same dimensions or we can't add them. Now, in your calculator, we're going to put in matrix A and we're going to put in matrix B. So we're going to turn mine on. We're going to go second matrix and we're going to edit A. Just rewrite over this. When you rewrite over this, it'll reset it. A 2 by 3. And now you can put your points in there. 0. Okay, as soon as you put them in, make sure you enter the last one. Make sure you quit. Now, go to matrix B. Edit. Come down to B. Put matrix B in. It is a 2 by 3. As soon as you put your new dimensions in, it kicks in for you. So rewrite right over whatever was there. And quit it. Now, if you want to make sure that you have what you need in your matrix, again, second matrix, click on A, and say, show me what I put in A. There's A. Make sure that it's what you wanted to put in. Click on matrix B. Come to B, click on B. Say, yep, that's what I wanted to put in also. Right? Now, to add these two matrices, you go like this. Pull up the A, put a little plus sign, pull up the B. Remember, these are the names for these guys. This is how we name them. Come down here, and this is called matrix B. So I'm telling my calculator, whatever you have in A, add to B. And it adds them. And there's my resulting matrix. If I want to subtract them, it'll subtract them element for element. I just say subtract. Remember, they have to be corresponding. They have to both be the same dimensions. So it subtracted 0, and I went this way, A minus B. 0 minus 1, negative 1. 1 minus 0, 1. Negative 2 minus 3, negative 5. See it? It'll add, it'll subtract, element for element. Okay? So we can add and we can subtract as long as they're the same dimension. These are two different dimensions. This is 2 rows, 3 columns. What is this one? What dimension is this one? 3 by 2. These are not the same. So therefore, we say undefined. Can't do this. Whoa. you tried to take this element for this element, this element for this element, you can kind of see they're not matched up. It has to be if and only if they are the same size.
Wait, can we go back up for just 1 second?
Yeah, absolutely. We added them element for element. They have to be the same. So we did this. 0 plus 1, 1. 1 plus 0, 1. We could subtract them as well. They have to match up. And we put them in your calculator, and then we did it in A plus B on your calculator. Okay, now, scalar multiplication. Scalar multiplication is when you just multiply a matrix by a specific number, a scalar number. So if I want to do 3A, that means I take my matrix A and I multiply everybody by 3. That's all it means, every element by 3. So it would just come out, multiply 2 times 3, 6. 2 times 3, 6. 4 times 3, 12. Negative 3 times 3, negative 9. 0 times 3, 0. Negative 1 times 3, negative 3. 2 times 3, 1 times 3, 2 times 3. So scalar means multiply every element by that one particular number. You can have any dimension you want because you're multiplying every element. Now if it says 3A minus B, all I have to do is take this guy, which is my 3A, and element for element. 6 minus 2. 4. 6 minus 0. 6. 12 minus 0. 12. So you see what I'm doing? Again, element for element. You can put this in your calculator, matrix A, matrix B, and you could just give this statement, just like that. It'll multiply it by 3, then it'll subtract B in your calc. Good? Okay, just to go over some of the things that we can do with your matrices. Now, if you have to solve for x in this equation, not that we do this too often, but if we're going to solve for x, we're going to set this equation up so that x is by itself. We're going to subtract a. And then we're going to divide by 3. Dividing by 3 is the same as taking 1/3 of b minus a. So you can put a in your calculator, put b in your calculator, and then in your calculator, just say 1/3 parentheses, God bless you, God bless you, minus a. And this will work for you. So if they give you an equation and they want you to solve for x, so solve your equation first for x, and then load your matrices in there, and put that statement right in your calculator. Make sense? So why don't you guys try this one? Load those two in your calculator a little different. Yes, you can put this in your calculator, but the only thing we require you to do is to be able to multiply this out. So the first thing we need to see is the dimensions. This is a 2 by 3. This is a, this is a, backwards, a 3 by 2. And this is a 2 by 2. To multiply, these guys have to be the same. This is not like adding and subtracting. So you're going to list the dimensions of the first one. You're going to write right next to it dimensions of the second one. The two inside ones have to be the same. This is your resulting matrix. Your resulting matrix is going to be a 3 by 2. Now, this is how we multiply. We take the first row and we multiply it by the first column. Element for element. So I like to write these out so you see them. So I multiply -1 times -3. -1 times -3. Then I say plus 3 times -4. Good so far? Then we take a little break. We multiply the first row by the second column, element for element. -1 times 2 plus 3 times 1. Write them out first because I want to show you something really, really good about this. Now we're going to do the next column, next row. Next row, first column, element for element. 4 times -3 plus -2 times -4. Take a little break. Go to the second column. Plus 4 times 2 plus -2 times 1. Last one. Last row. Row times column. 5 times -3 plus 0 times -4. Take a little break. Do the last column. 5 times 2 plus 0 times 1. Now, watch up here. If we did this right, yes.
How come those two have pluses and the last one doesn't?
Oh, I just forgot the plus. Yeah, sorry. Notice, look at this pattern. -3, -3, -3, -4, -4, -4. 2, 2, 2. 1, 1, 1. Look where they come from. -3, -4, 2, 1. See the pattern? Now, watch the other row. -1, 4, 5. -1, 4, 5. See it? 3, -2, 0. 3, -2, 0. Then it's going to repeat itself. -1, 4, 5. 3, -2, 0. If all of that works, you know you did it right. If there's something off, like if this was -4, and I had -3, -3, doesn't belong, -4, right? I must not have looked right. Now, keep these like they are. We took a break here. We needed a 3 by 2. Do we have 3 rows?
Mm-hmm.
Do we have 2 columns?
Mm-hmm.
So we're going to add this piece together like this. So -1 times -3 is 3, plus -4 times 3, -12. And what is -12 plus 3? -9. We're starting our matrix. We're going to build a 3 by 2. To this guy, -2 plus 3. 1, right? Do this. If you want, you can do this whole part right in your calculator, if you like. You don't even have to do them separate. You can put it in your calculator just like that. -12 plus 8. -15 plus 0. That's a -15. Sorry. Plus, this is 8 plus -2. And 10 plus 0. There's my matrix. There's my answer. Now you can put it in your calculator to check it. If it can't be multiplied because the dimensions didn't line up right for this, it will say mismatched or undefined. I forgot which one it says. If we can't do it because the dimensions don't match up, we just say undefined.
So we have to know how to do that.
This is the one you have to know how to do. The rest you can use your calculator, and you can certainly check it in your calculator, but you have to know how to do this one. I find if you write these out, you pretty much can't miss, because everything has a pattern here.
It's going to be a small one and then A
Oh, no, it could be different. Yeah, it could be different. But you have to be able to do this to it. You have to match the insides. Like, for instance, do I have another one? Let me see if I have another one here. So, small one on the A, right? What's the dimensions of this guy? 2 by 3. What's the dimensions of this guy? 3 by 3. So did these match up? Yep. So this is a 3. And our resulting matrix is a 2 by 3, which means we're going to get 2 rows, 3 breaks this time, which makes sense because these have the 3 columns, don't they? So this is what's giving me my columns, the second one.
Wait, how do you know what the result is?
So this is row, 2 rows, 3 columns. This is 3 rows, 3 columns. These 2 middles have to be the same.
Oh, so then take the outer?
And then these is what's left for your resulting matrix. So, ready to multiply? First row, first column. So 1 times negative 2. Just put pluses in between. Then what? 0, 1. 3, negative 1. Take a break. How many of these breaks are we going to have? 3. Because we're 2 by 3, right? So, we've got another column to do. So, 1 times 4 plus what? 0, 0, 0 plus 3, 1. Good. Take a break. Go to the last column. 1 times 2 plus 0 times 0 plus 3 times negative 1. It's not that big. I won't give you something that's really huge. Now, last row. Take the first column. What is that going to look like?
2 negative 2.
2 times negative 2 plus
Negative 1.
negative 1 times 1.
Negative 2, negative 1.
Negative 2, negative 1. Good. Take a break. Go to the next column. Is everybody following us? Okay, next column. 2 times what? 4. Can you almost see it right here? Plus negative 1 times 0 plus negative 2 times 1. Last one. Last column. 2 times what? 2 plus negative 1 times
0.
plus negative 2 times
Negative 1.
negative 1. You're done. Now, before you do this, just eyeball this. Oh, look at this. There's your column 1, 2, 0, 1, 3, negative 2. 1, 2, 0, 1, 3, negative 2. 1, 2, 0, 1, 3, negative 2. See your columns? Then see your other ones? There's your negative 2, there's your 1, there's your negative 1. First column. 4 zeros, 1. Second column. 2, 0, negative 1. Now, put this whole thing in your calculator and give me an answer. The zeros are nice, they come out. Negative 2 plus negative 3? Negative 5. Okay, put this guy in. What do we get? Got 7? Negative 4?
Oh, no, that's negative 3.
Negative 3. Good. Okay, this guy, the 0 comes out. Gotten 7. Good. The 0 comes out. So what is 8 plus a negative 2?
6.
6. This 0 comes out. 2 plus a negative 3.
2.
This 0 comes out. 2 plus 2. I'm sorry, 4 plus 2.
6.
6. There's your result. Okay? It has a pattern. It has a pretty nice pattern. I think that was all yeah, that's all I have for you. Do you have any questions on this?
Can we do